Hello, the beautiful people, and welcome back to another KYJ, Knowing Your Jargon. This is our alphabet series, and if you've been following A, B, C, D, E, F, G, today is letter H. Let's get started. So a word I struggled with when I first started nursing, and that I think a lot of students in nursing and paramedicine and even in medicine probably struggle with right at the very beginning, is homeostasis. Homeostasis. What does it mean to be homeostatic? So homeostasis means balance. So if we think about the balance of the pH of our blood, when we're in homeostatic balance, then our blood pH is within its normal range. If we think about fluid homeostasis, we're looking at body water between the three compartments, the intracellular, the interstitial, and the vascular space. There is a homeostatic balance in saltiness, and a homeostatic balance in osmolality, and a homeostatic balance in glucose. Homeostasis means balance. And so as our body struggles to maintain homeostasis, it uses energy to do that. Homeostasis, balance. Okay, so in the class we've been doing diabetes emergencies, and we've been talking about hypoglycemia and hyperglycemia. So let's have a talk about that one. Now the values that I use are the values that we use in Australia. So a hypoglycemic event is going to be different depending on whether a person is diagnosed with type 2 diabetes or type 1 diabetes. So normal ranges for somebody with type 2 diabetes in a fast would be 6 to 10. Well, not normal ranges, but that's our target range with a patient that's got type 2 diabetes. So we really want to keep their blood glucose levels somewhere around that 6 to 10. In type 1 diabetes, it's 4 to 8. Now, if a person with type 1 diabetes therefore has a blood sugar level that drops or slumps below 4 and they're symptomatic, then that technically is a hypoglycemia. And for that reason, we should treat it. And so we're going to give a short-acting sugar and a long-acting sugar, something like a starch, a bit of bread, sandwich or something. And if they can't have something to eat, like let's say it's not safe for somebody to be able to ingest food, their level of consciousness is altered, then we're probably going to give them glucagon or some glucose intravenously. So glucagon as an IM or a subcut injection, or some intravenous glucose. So that's our H word, is hypoglycemia. Okay, so our next H word is, see what I did there? That was a hiatus. Hiatus. That's our next H word. Hiatus means a pause, but in medicine we often refer to a hiatus hernia, and that's where a loop of the stomach sort of punches up through the diaphragm and comes into the chest. A little bit of stomach pops up through the diaphragm and into the thoracic cavity. That herniation through the diaphragm wall, that's called a hiatus hernia. Hiatus hernia. It's our H word. You know, if you take blood and you've got to agitate that blood a little bit to sort of mix it in the tube before you set it down, or you put it into the spinner, or you send it in the Lamson tube, or you send it away to pathology. And occasionally pathology will ring you up and say, we couldn't use that sample, it was hemolyzed. Well, hemolysis, let's have a look at that H word. Hemolysis is when red blood cells burst. Now, they can be burst by when we take the blood. If we shake that blood, that can burst our red blood cells, so that can hemolyze them. They can also become hemolyzed with certain drugs, certain chemicals. Some snakebite venom will actually cause a hemolysis. Some chemicals that are released from bacteria, particularly hemolytic streptococcal bacteria, so beta hemolytic streptococci. These bacterial infections, when they come into our blood, they can actually cause red blood cells to burst. Now, inside red blood cells, there is that protein called hemoglobin. That's going to be our next H word. But hemoglobin's red. And so if red blood cells burst, they leak that red hemoglobin into the plasma, and the plasma, instead of being clear and urine coloured takes on a pink rosé colour. And this is how the laboratory technician or the pathologist could pick up that test tube and look at it and go, no, I can't test that, that's haemolysed. The big problem with haemolysis is that inside those red blood cells is a high concentration of potassium. So if they burst, that potassium leaks out, it gets into the serum, and of course the potassium values and some other values on that lab test, the potassium values are going to be artificially elevated. So you don't get an accurate potassium if you've got a haemolysed sample of blood. Look after it, protect it, package it well, and try not to break your blood. Hemoglobin. Hemoglobin is a protein, and it's inside your red blood cells. It makes up a large portion of your red blood cells, hemoglobin. You've got around about 250 to 300 million molecules of hemoglobin inside every red blood cell. And hemoglobin's dominant role, it's got a lot of little jobby jobs, but its dominant role is to hook on to oxygen. A hemoglobin molecule can hold 4 oxygen, and when all 4 little receptors on the hemoglobin molecule are holding an oxygen, we would say that hemoglobin is fully saturated. We would say it's a saturated hemoglobin. We measure that with a little probe that we put on a finger called an SpO2. Of course, I can also measure hemoglobin saturation by taking an arterial blood sample. And when I measure the saturations of hemoglobin, oxygen, on an arterial blood sample, that's not called an SpO2 like it is on your finger. It's then called an SaO2. So an SaO2 is an arterial sample saturation, and SpO2 is a pulsatile oxygen hemoglobin sample. So there it is, hemoglobin. Okay, so we're done. So that's our 5 H's. Although yesterday I promised that I was going to do Helicobacter pylori. So this is this nasty little spiral-shaped bacteria that was discovered maybe 20 years ago as the cause of stomach so gastric and duodenal ulcers. So this little bacteria, when it colonizes your gut, clusters of this bacteria start to cause ulceration and can lead to certain types of tumours, so tumours like mold in your gastric lining. So gastric ulceration and duodenal ulceration, thought to be due to, important consideration is that it's due to Helicobacter pylori infection, and we can eradicate it. So there's an eradication therapy available, usually involves a couple of antibiotics and a proton pump inhibitor to stop acid production, and hopefully your gastric mucosa sort of heals over. Don't rip a hole in your guts, I suppose. Well, that's our H's. I hope you've had enough. Tomorrow we're going to do I. I've got to think of some I words now. If you've got any, put them in the comments. See you tomorrow. I forgot one. I wanted to talk about hemostasis. Hemostasis, stopping bleeding. Hemostasis. It involves 3 steps. We should probably cover each of these steps separately, although I've done other videos on some of them. So, hemostasis involves vasoconstriction, so the blood vessels constrict down. When you're bleeding, you've popped a blood vessel and now you've got to stop bleeding, so your blood vessel autonomically starts to vasoconstrict to slow down blood flow. The second step that happens is platelets start to come to that area and they clump and they start to form a primary platelet plug. That process is called clotting. And then those platelets will signal to the plasma to start to form little strands of solid string material called fibrin. And that chemical chain reaction from plasma proteins, coagulation factors they're called, that's called coagulation. So there you go, coagulation, clotting and vasoconstriction. Together those 3 things are called hemostasis. See you tomorrow.